Hey guys, welcome to Life Noggin. So there is this idea floating around out there that we could just turn all our plastic waste back into oil and then just keep recycling it over and over again forever. And while this sounds pretty crazy, it's actually something that's already being done through a process known as pyrolysis. So let's take a look at how we can turn plastic back into oil. Today we're diving into the fascinating world of pyrolysis, a process that transforms plastic waste into valuable resources like oil. Pyrolysis is derived from the Greek word pyros meaning fire and lysis meaning to break down or to split. In simple terms, pyrolysis is a chemical process that uses heat to break down plastic waste into its basic building blocks, which can then be used to create new products or transformed into energy. But what actually happens during pyrolysis? Well, let's dive into it. Pyrolysis typically takes place into stages. Stage 1 involves heating the plastic to a high temperature between 400 degrees Celsius and 600 degrees Celsius, which is about 750 degrees Fahrenheit and 1000 degrees Fahrenheit. This heating process occurs in the absence of oxygen or in an oxygen-free environment, which is why pyrolysis is considered a type of thermal depolymerization. At these high temperatures, the plastic molecules start to break down their long chains into smaller molecules called monomers. Monomers are the basic building blocks of plastics and other organic compounds. During this stage, the plastic undergoes significant chemical changes resulting in the formation of various hydrocarbons. Stage 2 involves separating and collecting the products of the reaction. As the hydrocarbons condense, they form liquid and gaseous states which are separated based on their boiling points. The liquid fraction is known as pyrolysis oil or pyoil. It's a complex mixture of hydrocarbons similar to crude oil. The gaseous fraction consists of smaller molecules such as methane, ethane, propane, and butane. These gases can be used as fuel or further processed into liquids. Additionally, a solid residue called char is often left behind after the pyrolysis process. Char can be used for various purposes including as a fuel source or in cement production. Now you may have noticed that I've been saying plastic waste as if it is one kind of thing when really plastic is made up of thousands of different kinds of polymers. So how does pyrolysis work for all those different plastics? To answer that question, let's first look at what plastic is actually made of. The most common plastics are made from polymers, which are large molecules composed of repeating structural units called monomers. Polymers are created by linking together many monomers through chemical reactions. For example, polyethylene, commonly used in plastic bags and bottles, is made from the monomer ethylene. Plastics are categorized into different types based on their chemical structure and properties. Some of the most prevalent types include polyethylene terephthalate, PET or PET, polyethylene, PP, polystyrene, PS, polyvinyl chloride, PVC, and polycarbonate, PC. However, not all plastics are suitable for pyrolysis. Each type of plastic requires a specific temperature range for effective depolymerization. For instance, low-density polyethylene, LP, and polypropylene, PP, can be depolymerized at relatively lower temperatures around 400 degrees Celsius to 600 degrees Celsius. On the other hand, PET and PVC need higher temperatures ranging from 600 degrees Celsius to 800 degrees Celsius to break down successfully. So the question becomes which plastics can actually be used for pyrolysis. The answer lies in understanding the molecular structure of certain polymers. Pyrolysis works best on plastics with nonpolar and symmetrical molecules like polyethylene, PP, and polystyrene, PS. These plastics can be depolymerized efficiently, yielding high-quality pyrolysis oil. However, plastics like PET and PVC containing polar groups or asymmetrical structures present challenges due to their complex depolymerization pathways and the formation of undesired byproducts. Despite these challenges, ongoing research explores methods to improve the pyrolysis of these plastics, making the process more comprehensive. One of the main advantages of pyrolysis over other plastic waste management options such as landfills and incineration is that it produces a resource that can be used to generate electricity or heat. This contrasts with traditional incineration, which primarily uses plastic to generate heat, with less focus on resource recovery. By converting plastic waste into valuable products, pyrolysis reduces the need to rely on fossil fuels, contributing to a more sustainable energy future. Moreover, The oil obtained from pyrolysis can be used as a feedstock for producing chemicals and fuels, reducing the demand for petroleum-based products. Pyrolysis also offers a solution to the problem of plastic leakage into the environment. By recycling plastic through this process, we can prevent the accumulation of plastic waste in landfills and oceans, preserving natural habitats and reducing the risk of microplastic contamination. Of course, pyrolysis isn't perfect and comes with some challenges and limitations. One major challenge is that the process is energy intensive, requiring significant amounts of heat to break down the plastic molecules. This high energy consumption can increase operational costs and make the process less economically viable. Moreover, the efficiency of pyrolysis depends on factors like temperature, heating rate, and residence time. Optimizing these parameters can be complex and requires careful monitoring and control. Another limitation is the need to sort and process different types of plastic waste before pyrolysis. Not all plastics are easily separated, and the presence of contaminants can impact the quality of the final products. Additionally, the products of pyrolysis, particularly the gas and char, may contain impurities such as dioxins, furans, and polycyclic aromatic hydrocarbons, PAHs. These impurities can pose environmental risks if not properly managed. In spite of these challenges, pyrolysis holds immense potential for addressing the global plastic waste crisis. Its ability to transform plastic into valuable resources offers a sustainable solution to plastic pollution and resource depletion. By harnessing the power of pyrolysis, we can move towards a circular economy where waste is minimized and resources are conserved. Overall, the process looks pretty promising. When looking at the benefits, it seems like a great way to recycle plastic waste. But it's important to consider both the positive and negative aspects to get a balanced perspective. As we continue to grapple with the plastic pollution crisis, it's important to explore all available solutions. Pyrolysis emerges as a beacon of hope in the battle against plastic waste. By breaking down plastic into valuable resources, this innovative process offers a pathway to a more sustainable future. While challenges remain, ongoing research and technological advancements are paving the way for wider adoption of pyrolysis. Embracing pyrolysis as part of a comprehensive waste management system can help mitigate plastic pollution and reduce our reliance on fossil fuels. But remember, while pyrolysis is a powerful tool, it's not a silver bullet. Reducing plastic usage and improving recycling infrastructure remain crucial in tackling this complex issue. Only through a combination of efforts can we truly turn the tide on plastic waste and preserve our planet for future generations. Now, here's the cool thing about this topic. There's a lot of opportunity for you to help shape what we cover next. Your comments on this video will help us decide what topics we should cover in the future. So please leave your thoughts below. Do you think pyrolysis is the answer to our plastic waste problems, or are there other solutions you'd like to see us cover? What topics related to plastic recycling would you like us to explore? And hey, if you're still watching, why not stick around for more fun science stuff? Click the subscribe button to join the noggin and be notified every time we release a new video. Thanks for coming along on this journey through the fascinating world of plastic recycling. Keep those creative ideas flowing, and together we'll continue to unravel the mysteries of science and technology. So what do you think? Would you use pyrolysis to recycle plastic waste? Share your thoughts in the comments section below. Your opinions matter and we value your input. Also, if you enjoyed this video, don't forget to hit the like button and share it with your friends. By doing so, you'll not only spread awareness about plastic recycling, but also support us in creating more engaging science videos. Remember, every small step counts in protecting the environment. Let's continue to learn, explore, and make a difference together. So that's it for this round. Thanks for joining me. If you want to watch more, you can click right here or click here. See ya.